Article 430.74 of the National Electrical Code specifically addresses the requirement for disconnecting motor control circuits from all sources of power. This section mandates that motor control circuits be arranged in such a way that they can be completely de-energized from their power source. The key implication of this requirement is the necessity of installing a disconnect switch or circuit breaker ahead of the magnetic starter in the motor control circuit. The primary reason for this requirement is safety. When performing maintenance, repairs, or inspections on a motor or its control circuit, it is crucial to ensure that the entire system is energized. A disconnect switch or circuit breaker located before the magnetic starter allows for the complete isolation of the motor and its control circuit from the electrical supply. This prevents accidental energization during work, which could lead to electrical shock, injury, or even fatal accidents. The disconnect switch or circuit breaker provides a clearly visible and accessible means of cutting off power to the motor control circuit. This is particularly important in industrial environments where multiple personnel may be working on different parts of the electrical system simultaneously. A disconnect ensures that the motor cannot be inadvertently started or energized while someone is working on it. The specific wording of Article 430.74 emphasizes that the motor control circuits must be arranged to be disconnected from all sources. This means that all potential sources of power to the control circuit, including control transformers, auxiliary power supplies, and any other source that could energize the circuit, must be capable of being disconnected. The disconnect switch or circuit breaker should be readily accessible and clearly labeled to indicate its function. It should be located in a position where it can be easily operated by authorized personnel. In many cases, the disconnect switch is mounted directly on or adjacent to the motor starter enclosure. The disconnect switch or circuit breaker must have an ampacity rating suitable for the motor control circuit it is intended to disconnect. The rating should be sufficient to handle the full load current of the control circuit, as well as any potential fault currents that may occur. The type of disconnect switch or circuit breaker used should be appropriate for the application and the environment in which it is installed. Factors to consider include the voltage rating, the current rating, the interrupting capacity, and the environmental protection rating. In some cases, a fused disconnect switch may be required to provide additional overcurrent protection for the motor control circuit. A fused disconnect switch combines the functions of a disconnect switch and a fuse holder in a single unit. This provides both a means of disconnecting the circuit and a means of protecting it from overcurrents. The National Electrical Code provides specific requirements for the selection and installation of disconnect switches and circuit breakers in motor control circuits. These requirements are intended to ensure the safety and reliability of the electrical system. It is important to consult the NEC and other applicable codes and standards when designing and installing motor control circuits. There are several different types of disconnect switches that can be used in motor control circuits. These include fused disconnect switches, non-fused disconnect switches, and circuit breakers. Fused disconnect switches provide both a means of disconnecting the circuit and a means of protecting it from overcurrents. They are typically used in applications where overcurrent protection is required. Non-fused disconnect switches provide only a means of disconnecting the circuit. They are typically used in applications where overcurrent protection is provided by a separate device, such as a circuit breaker. Circuit breakers provide both a means of disconnecting the circuit and a means of protecting it from overcurrents. They are typically used in applications where overcurrent protection is required and where it is desirable to have a resettable overcurrent protection device. The selection of the appropriate type of disconnect switch or circuit breaker will depend on the specific requirements of the application. In addition to the disconnect switch or circuit breaker, motor control circuits may also include other components such as control transformers, relays, and pilot devices. Control transformers are used to reduce the voltage of the power supply to a level that is suitable for the control circuit. Relays are used to switch control circuits on and off. Pilot devices are used to provide input signals to the control circuit. The National Electrical Code provides specific requirements for the wiring and installation of motor control circuits. These requirements are intended to ensure the safety and reliability of the electrical system. It is important to consult the NEC and other applicable codes and standards when designing and installing motor control circuits. Furthermore, let's expand on the specific implications and considerations for three-phase, 480-volt, 1 horsepower fan motors with magnetic starters in an industrial plant setting, particularly concerning disconnect means and compliance with NEC Article 430.74. Firstly, the presence of three-phase, 480-volt power indicates a common industrial power distribution system. This voltage level is frequently used for powering machinery and equipment due to its efficiency in transmitting power over longer distances compared to lower voltages. Secondly, a 1 horsepower fan motor is relatively small, but the aggregate number of such motors in a plant can be substantial, leading to significant overall power consumption and potential safety concerns. The fact that these motors are equipped with magnetic starters is typical for industrial applications. Magnetic starters provide overload protection and remote control capabilities, allowing for safe and efficient motor operation. Magnetic starters also often include undervoltage protection, which is critical for preventing unexpected restarts after a power outage. The core issue revolves around the absence of disconnect means at each motor location, relying solely on the breaker panel for disconnection. While this might seem adequate, it poses significant safety risks and potential code violations. Article 430.74 as highlighted, mandates that motor control circuits be arranged so they can be disconnected from all sources of supply. This requirement is not merely a suggestion but a fundamental safety measure. The disconnect switch or circuit breaker needs to be readily accessible and located in sight from the motor and driven machinery location. This is crucial for several reasons. 1. Worker safety. When maintenance or repair work is needed on the fan motor or its associated components, a local disconnect allows a worker to positively de-energize the circuit right at the motor. This eliminates the need to rely on someone else to switch off the correct breaker to remote panel, reducing the risk of human error and accidental re-energization. 2. Compliance. Meeting the NEC requirements ensures that the electrical installation is safer and compliant with industry standards. Failure to comply can result in fines, insurance complications, and potential liability in the event of an accident. 3. Efficiency. Walking back to the breaker panel each time a motor needs to be de-energized is time-consuming and inefficient. A local disconnect saves time and improves the overall efficiency of maintenance operations. 4. Prevention of arc flash hazards. Disconnecting a motor circuit at the breaker panel under load can create an arc flash hazard, particularly if the breaker is not properly rated or maintained. A local disconnect, especially a fuse disconnect, can mitigate this risk by providing a safer means of interrupting the circuit. Considering the close proximity of some fans to the panel supplying the branch circuits, it might be tempting to argue that the breaker serves as an adequate disconnect. However, the NEC generally requires a disconnect to be within sight of the motor, typically defined as being visible and not more than 50 feet away. This ensures that the person working on the motor has positive control over the power source. In situations where the breaker panel is not within sight of the motor, a local disconnect is unequivocally required. When installing disconnects for these fan motors, several factors must be considered. Firstly, the disconnect must be horsepower rated for the motor. A 1 horsepower, 480 volt, three-phase motor will have a specific full load amperage, which the disconnect must be rated to handle. Secondly, the disconnect should be suitable for the environment. If the plant environment is dusty, wet, or corrosive, the disconnect enclosure must be appropriately rated, such as NEMA 4 or 4X, to protect against these conditions. Thirdly, the disconnect should be lockable in the off position. This is a critical safety feature that allows maintenance personnel to lock out the disconnect, preventing accidental re-energization while work is in progress. Lockout-tagout procedures should always be followed. Fourthly, the disconnect should be clearly labeled to indicate the motor it serves. This prevents confusion and ensures that the correct motor is de-energized. Fifthly, if the disconnect is a fuse disconnect, the fuses must be correctly sized to provide overload and short circuit protection for the motor. The fuse sizing should be based on the motor's nameplate data and the recommendations of the motor and starter manufacturers. Article 430 of the NEC provides detailed guidance on motor protection and control circuit requirements. To summarize the installation process, firstly, identify the full load amperage flaw of the 1 horsepower 480 volt motor from its nameplate. Secondly, select a disconnect switch that is horsepower rated for 1 horsepower at 480 volts and has an amperage rating greater than or equal to the motor's FLA. Thirdly, if using a fuse disconnect, select fuses that are sized appropriately for the motor's FLA, typically not exceeding 125% of the FLA for standard and first-time fuses, in accordance with NEC guidelines. Fourthly, mount the disconnect switch within sight of the motor, ensuring it is readily accessible. Fifthly, wire the disconnect switch into the motor circuit, ensuring that all connections are made properly and torqued to the manufacturer's specifications. Sixthly, label the disconnect switch clearly to indicate the motor it serves. Seventhly, implement a lockout-tagout procedure to ensure that the disconnect switch can be locked in the off position during maintenance. Eighthly, verify that the installation complies with all applicable NEC requirements and local codes. In addition to the disconnect requirements, it is also important to ensure that the motor control circuit itself is properly protected. This includes providing overload protection for the motor, typically through the use of overload relays in the magnetic starter. The overload relay should be sized to protect the motor from overheating due to sustained overloads. It is also important to provide short-circuit protection for the motor control circuit, typically through the use of fuses or circuit breakers. The short-circuit protection devices should be sized to protect the circuit from damage due to short circuits or ground faults. Grounding is another critical aspect of motor control circuit safety. The motor, the starter enclosure, and the disconnect switch should all be properly grounded to provide a low impedance path for fault currents. This helps to prevent electrical shock hazards and ensures that overcurrent protection devices will operate properly in the event of a fault. Regular inspections and maintenance of motor control circuits are essential for ensuring their continued safe and reliable operation. Inspection should include checking the condition of the wiring, the tightness of connections, and the operation of the disconnect switch and overcurrent protection devices. Maintenance should include cleaning the equipment, lubricating moving parts, and replacing any worn or damaged components. Proper training for personnel who work on motor control circuits is also crucial. Personnel should be trained in the hazards of electricity, the proper procedures for working on electrical equipment, and the requirements of the NEC and other applicable codes and standards. It is important to keep accurate records of all inspections, maintenance, and repairs performed on motor control circuits. These records can be used to track the performance of the equipment, identify potential problems, and ensure that maintenance is performed on a regular basis. By following these guidelines, it is possible to ensure that motor control circuits are installed and maintained in a safe and reliable manner. This helps to protect workers from electrical hazards, prevent equipment damage, and ensure the continued operation of the plant. The installation of disconnects before magnetic starters for 480 volt, 1 horsepower, 3-phase fan motors is not just a matter of compliance, it is a fundamental safety practice. It protects personnel, improves operational efficiency, and reduces the risk of electrical incidents. By adhering to NEC Article 430.74, and implementing proper disconnect procedures, a safer and more productive work environment is ensured. In summary, to ensure full compliance with NEC Article 430.74, and enhance safety for 3-phase, 480 volt, 1 horsepower fan motors equipped with magnetic starters. Firstly, install a horsepower rated disconnect switch within sight of each motor location. Secondly, ensure the disconnect switch is suitable for the environmental conditions and is lockable in the off position. Thirdly, properly size fuses if using a fuse disconnect switch to provide adequate overcurrent protection. Fourthly, clearly label each disconnect switch to identify the motor it serves. Fifthly, implement and enforce lockout-tagout procedures during all maintenance and repair activities. Sixthly, provide comprehensive training to all personnel working with these motor control circuits. By taking these steps, the risk of electrical hazards is significantly reduced, and a safer, more efficient working environment is fostered. Furthermore, in a broader perspective, consider the integration of these safety measures within a comprehensive electrical safety program. Such a program should encompass regular training, periodic inspections, and adherence to industry best practices, thereby cultivating a safety-conscious culture across the entire plant. Remember, safety is not really a matter of compliance, but a fundamental value that protects the well-being of every individual and ensures the operational integrity of the entire facility. The consistent application of these principles fosters an environment where safety is not an afterthought, but an integral part of every task, decision, and procedure. In conclusion, remember to prioritize the implementation of readily accessible disconnects for your 480-volt fan motors. These disconnects should be installed upstream of the motor starters,